In this video, we're talking about various inequalities in triangles. The first one we talk about is a corollary to the triangle exterior angle theorem. And just to remind you of that theorem, it is the theorem where you have a triangle and we draw in an extension of one of the sides, and we know that the angle 1 is equal to the measure of the angle 2 plus measure of angle 3. And we've gone through and proven that before. Well, what the corollary to the triangle exterior angle theorem says, that an exterior angle of a triangle is greater in measure than either of the remote interior angles. And so the nice thing about that is we know it's true because the measure of angle 1 is equal to 2 plus 3. If 2 and 3 both have value, if you take away one of them, then measure of angle 1 needs to be greater than that. So that's all this is saying is measure of angle 1 is greater than 2, or measure of angle 1 is greater than measure of angle 3. That is what this theorem is telling us. Okay, and then we have a couple other theorems. The first two are similar to each other. So theorem 5.10 says if two sides of a triangle are not congruent, which, by the way, this reminds us of the Isosceles triangle theorem, which starts out with if two sides of a triangle are congruent. And remember, that theorem says opposite angles are also congruent. Well, this one's saying that if they're not congruent, then the larger angle lies opposite the larger side, the longer side. So instead of them being congruent, they're ordered in the same way as the angles, lies opposite the longer side. And then theorem 5.11 just says the exact opposite of this, and it says if two angles of a triangle are not congruent, again, remember, like the isosceles triangle theorem that starts the converse of the isosceles triangle theorem that starts off with if two angles of a triangle are congruent, then opposite sides are also congruent. This one says if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. And so basically what this says is we can order the angles based on the sides, or we can order the sides based on the angles. And we just look at the opposite for those. And then the last one is a very important theorem, and it'll come up over and over again in math as you get into higher level math. And it's called the Triangle Inequality. And what the Triangle Inequality says is the sums of the lengths of any two sides of a triangle is greater than the third side. Now, usually the way we think about this, than the third side, is we are thinking about the two smallest sides are always going to be greater than the longest side. That's the most relevant way to think about it. But what it's really saying is if you have a triangle and we label the sides A, B, and C, then triangle inequality says A plus B is greater than C. I think it's easiest to understand why this is by thinking about walking. If I wanted to go from this point to this point, from B to A, certainly I would choose to go C, assuming it's flat, just like the other two directions are, because we intuitively know the shortest distance between 2 points is a straight line. So if we were to go here and then here, that would be a longer distance. And that's basically what the triangle inequality is telling you. All right, so a couple quick examples. List the sides of the following triangle from least to greatest. Well, when you do this, it's easiest just to find all the angles first. And so our other angle is going to be 180 minus 92 minus 31, so 57. And then we can just apply the theorem and say that the ordering of the angle sides is equal to the opposite of the angles. And so if the smallest is, it says from least to greatest, if the smallest angle is 31 degrees, the smallest side is AB. So we know that AB is shorter than, well, the next one is 57, and so AC. And then the longest side is opposite. And of course, if you have an obtuse angle, that means it's automatically the largest angle because you can't have two obtuse angles in a triangle. And so that means BC is our largest side. For number 2, the sides of a triangle are 5 and 8. What is the range of possible values for the third side of the triangle? And so 5 and 8, what you do is you decide, well, what is going to be the, I'm going to let the third side be X, by the way. What is going to be the longest possible value in the triangle? Well, it could either be 8 or it could be X. If it was X, then the triangle inequality would tell us the two shorter sides, 5 plus 8, have to be greater than X, which means a constraint of the possible values is X has to be less than 13. X cannot equal 13. Now, this does not mean it's 12. Nowhere in this problem did I say that the sides have to be integers. They don't necessarily have to be integers. The other possibility for X is if 8 is the longest side, which means we would say 5 plus X is greater than 8. So X is greater than 3. So now we know that X is less than 13, but greater than 3. So we can look at it like this and say that the range of possible sides for that third value X is 3 to 13. Not equaling 3, not equaling 13, but it could be 3.1 or 3.001 or 12.9 or 12.95 or 12.98, but it can't be 13. 3, same deal. This time, if we let X be the longest, and we know 7 plus 7 has to be greater than X. And so we know that X has to be less than 14. But this one's different because it's isosceles. Two sides are the same. And it turns out that if you, it doesn't matter which one of those you choose to be the biggest. If you do 7 plus X is greater than 7, saying that this is basically saying X is less than 7, then X would have to be greater than 0. And so the answer here is 0 is less than X is less than 14. And then finally, it says order the segments in the picture from smallest to largest. Again, you're going to do like we did in the last one, where you're going to find the angle. And so this is going to be 55. We just subtract from 180. This one, you're going to get 43. You have to do the triangle separate. BC is not the smallest, even though it's opposite the smallest angle in the whole picture. So in this triangle, BC is the smallest. It's less than AC because 55 is greater than 40. But both of those is less than AB because 85 is the smallest. And then we also know that in these sides for this one, BC is the greatest in this triangle. The next greatest is opposite the 44, which would be BD. And then the smallest is CD. And so because the BC is the smallest in this one, but the largest in this one, the ordering would be CD, BD, BC, and then AC is bigger than BC, and AB is bigger than AC. And so that's your answer.